just in case. So this is normally you're the user here. You're the victim, if you want to classify yourself as a victim, and you're behind your corporate firewall, VPN, or whatever, and these are all the host names that you can see, but the outside world can't. Now, normally the bad guy out here, or anybody outside the zone, they can't connect into the zone at all, in a normal circumstances. However, what they can do is if you visit their website, any code that they're running on their web page, written in JavaScript, Flash, Java, ActiveX, or whatever it happens to be, will actually execute here in your web browser, and by extension be able to connect to these devices and do discovery and radio that information back out. It's actually quite simple once all the techniques were known about. One of the first steps that you have to be able to do, though, to intranet hack, which is find the internal NATed IP. You surf the externally with one IP, a public routable IP, and you have an internal NATed IP, which is the normal equation. And the best way to find out a user's internal NATed IP is through the use of a Java applet, or Java specifically, which can be called either using the MyAddress applet or one like it, or through Live Connect, where you can, using JavaScript, you can call Java sockets, specifically. All it's doing is it's creating a Java socket call, not making a request, just calling a Java socket, and pulling your NATed IP address out of the socket. It's actually a very quick hack, only a few lines of code, and you can get the address. Now, a lot of people out there, well, maybe in this room, a lot of people out there might disable Java, but you're not necessarily the victims, okay? The people sitting next to you on the cube walls that aren't the security experts, right? Those are the guys that are our attack targets. But when all said and done, everybody on the NAT is probably surfing with the same set of NATed IPs, either 192.168.0.1 or on the 10 networks. If you don't have it, they have it Java disabled, you can just guess it, and you have a pretty good statistic chance of just running through all the ranges and seeing what you get. It doesn't cost you anything. And by the way, we're going to kind of go through a lot of this stuff fast. There's a lot to cover, so if there's any questions, please stop us and let us know. I'll do our best to see the hands out there. It's kind of bright. One more step of review, which is JavaScript scanning for web servers out there, so you know what we're talking about. When you're on a bad guy's web page or come in contact with some JavaScript malware, what they'll do here is that they'll force your browser to make a series of requests, cross-site request forgery requests, using script tags. So they'll force your browser to connect to 192.168 or something on the internal network, and they'll route to the entire range. You can actually scan a whole class C in this way in probably under a minute or two, and it's really quick, really effective. Now what happens is that if the host is up, when you make a script source call, that web server will respond with HTML in a JavaScript context, meaning HTML will land in the JavaScript interpreter in the browser. It's a really quick hack. What that means is JavaScript is landing in the interpreter, causing a JavaScript console error. If there's an error, there's a web server there. If there isn't one, it's not there. Very quick to do blind port scanning using, or web server scanning using JavaScript, and it's very, very effective. Very quick. Now, I'll let Robert here cover some of the de-anonymizing stuff.
So a large part of this room probably knows what Tor is, but basically it's onion routing to try to anonymize yourself using a series of essentially proxy servers out on the internet that kind of switch, move around, and try to obfuscate where you're really coming from. So this is some sample stuff from their website. Using this Java socket call, basically it's making a connection out back to wherever it's being called from. So in this case, it's the attacker's web server. So not only am I able to get them to connect initially, I'm also able to get them to reconnect to me. And when that happens, you can see the first one is basically them connecting directly to badguy.com. And the second is them connecting to the Java call to, in this case, I sent them to log.cgi with two completely different IP addresses, the first being Tor, the Tor exit node, and the second being their real IP address. So
what was interesting about Java socket calls is that should your browser be proxied, should you be routing through Tor or whatever, the Java socket calls will actually not respect the proxy. They use their own network API to make their own outbound connections. So you're not actually proxying in those modes, and a lot of times people don't know that. So Tor does its best job to, in the first request there, to make it look like, okay, I'm an IE browser or something like that. And the second one is actually Robert in the test case using this code here, making that request. So that's Tor, that's him, and you can get the user's real IP of whatever network they happen to be on. So one way to de-anonymize if you thought you're safe in the anonymizing world out there.
Which is great because now I know your internal IP address potentially as well.
So they're real external and they're real internal. And there's another way to de-anonymize as well. I'll let you cover this one.
So this is basically a very small snippet of code, and it doesn't necessarily have to be any more complicated than this, but basically as long as you're making a UNC file share connection out to the internet, basically you're trying to say, I want to connect to some machine and do some file sharing back and forth between two Windows boxes. So if you're in Windows and you see that your browser will try to automatically connect NetBIOS out onto the internet, and it completely bypasses all the proxies in place.
Everybody's really quiet. Okay. So different de-anonymizing methods are in place. So it's not as straightforward as some would have you believe as far as keeping yourself anonymized. And at this point, a lot of the times, when we do this presentation out there, people turn to anger, and and they start venting at the web security experts sometimes, but also the browser developers. What the hell are they thinking with this stuff, right? But all these are brand new stuff. Their job out there, as far as the browser developers, to make web pages look pretty, not necessarily keep you and your internet secure. The things that we won't get to in this particular presentation, the different browser hacks that, because we simply don't have enough time to cover them, is that some new browser hacks are popping up that you can enumerate a user's Firefox extensions, the applications that are running on their system Windows. Actually, why don't you give them a for?
Yeah, there's a res colon and resource colon depending on which browser you're talking about that allow you to access and enumerate things that are on the local file system. We've actually experimented with ways to do this without JavaScript as well, but they're kind of hokey right now. They're not working very well. But we do have two different examples using res where we can either use timing attacks or just directly calling over and over and over again. And we end up being able to detect whether you do or do not have something installed, including patch levels and all kinds of other stuff. So.
And the other one, I believe this is Firefox specific, right? Compromising the password manager. Yeah.
This is one that's come up a number of times. We've actually seen this in the wild. People actually either use XSS to get it onto web servers that are vulnerable to XSS and have passwords that you're actually interested in, or they use some other type of exploit. But basically what they're trying to do is they put essentially the same form that you'd see that you put your username and password in, but Firefox, they fix this issue. But there's a lot of other password managers that just auto-fill that stuff, and when you see it's auto-filled, you automatically submit it off, and now you've got the username and password.
And so we have lots of different attack techniques on the browser, and that's all besides the never-ending supply of buffer overflows, cache poisoning techniques, URL spoofing techniques, and everything else. And there's also, I like doing the JavaScript HTML hacking and things like that. I think Robert enjoys more of the rich internet application stuff, specifically the Flash stuff. And so these are going to dramatically change the landscape, with Flash, ActiveX, Silverlight, Java, QuickTime, Windows Media Player, Acrobat. There's so much attack surface out there for a browser. It's impossible to actually be an expert at any. It's hard. I think I got a pretty good handle on the JavaScript security stuff. This Flash stuff just confuses me to death. So, but it's there. And what's the statistics on the Flash stuff? Like, what's the penetration out there?
It's high. It's in the 90s.
So, I mean, all the tricks. The DNS rebinding tricks. A lot of the JavaScript tricks will apply directly to LiveScript. So. It's all there. So, we've been through denial, so we know the internet's open. We've gone through anger, right? And then we come to bargaining, right? How do we solve this problem? We have to surf the web out there. And so what can we do? And people start to go, okay, I'll use, this is what they told us last year. Okay, we'll use no script, safe history, we'll install a VPN, and maybe turn off JavaScript if we can stomach in a bunch of other, crazy solutions out there and things like that. And we go, okay, we'll break those too. So one of the first target on the agenda was the Safe History extension. For those that don't know, the Safe History extension is a very good tool developed by the guys at Stanford. This was designed to prevent the JavaScript color hack, the CSS color hack, the history hack that we just showed. Great for defending against that because they'll only track or log the links on the site that, I hope I'm communicating it properly. So it would only show you, or you only get access to the visited links on the site that you clicked from. So there's a little bit of I guess what would you call it? You don't get the visited link in every site you go to, so there's a little bit of a trade-off there, but it helps if you really want to protect the privacy.
It's a slightly worse user experience, but it's a pretty good security measure.
So one way to defeat this is actually quite interesting. Now, particular URLs out there on websites, we'll pick on Google because we can, is particular URLs like this Gmail URL here. They will have this URL here. If you're logged into Google or Gmail, you will get your email back, right, if you're logged in. So you get one set of HTML. And if you're not logged in, you'll get the login screen, okay? So two different sets of HTML depending on if you're logged in. Same URL. Now, there's a ton of websites out there that have these particular URLs. So what you do here in this case is once you've got your victim, you force them to make a script source call to that particular URL. And the bad guy do is done some reconnaissance ahead of time and looked at the interpreter of what the code will error on. So if the user's logged in and you script source it in, the JavaScript interpreter will actually error on line, let's say, 8, and if they're not logged in, it will error on line 3. So you have a little Boolean test. So depending on what line number the user console errored on, you can actually tell not only where they've been, but if they're logged in, bypassing the safe history extension. So that was really easy. We set up like 5 test cases, like
Yep.
Gmail, Yahoo Mail, MSN,
Yep.
things like that.
The only thing you have to worry about is that there might be more than 2 states. So just keep up and understand that understand what all the states are and put that in. So there might be more than just 2. But.
And then we'll drop out of this one here. So then a lot of people said, okay, what about the no script extension to prevent what happens if we turn off JavaScript? Will that keep us safe? So I'm going to do that for you. And we're going to come back to the safe history one here, just in case, we have, actually, who in here turns off JavaScript or disables it? Raise your hands, please. Come on, I know there's more people than that. So probably 7 people, good. I think everybody's just worried about what we're going to display.
This is a security group, right? So, all right.
I don't think they were telling the truth. So what we're going to do here is you can't see it on the screen, but I'm going to disable JavaScript here. Little pop-down menu showing up on the other screen. Disable all JavaScript. And I'm going to hit reload. And your history is grabbed whether or not you have JavaScript disabled. And it will grab, everything is the same. The exact same effects are the same whether you have JavaScript turned on or not. So that doesn't help. And I'll show you how this works. And it's actually... Why we didn't think of it sooner? It's still beyond me.
You want me to tell you?
Okay.
So, basically how this works is if you use a visited link, there's a CSS attribute that allows you to include something if it's been visited. In this case, you're including an image. The image is not really an image. It's a CGI script with some specific parameter, that parameter being the site that you visited. So it's slightly slower than the JavaScript version, only because you have to make many requests over and over and over again as you find more things that you've actually visited. But it's actually very, very fast. So, we're still talking about within seconds, you can enumerate thousands of links.
I'll probably say a second, like for instance, we'll actually, I'll bring up live HTTP headers so you can actually see it work. There we go. So live HTTP headers, JavaScript is disabled. I'll hit reload. We'll go into live HTTP headers here. We'll row to the top. You can actually see it work. Where are we here?
Scroll down. Here.
So right here, here's the first one. If you're logged into Mail, it just uses that background CSS style to fire as a query string off domain. And you got it, and they're all in there. So it's about as quick as it gets. It's unnoticeable to the user. Here's another one here. I've been to mail.yahoo.com and things like that. So you can notice like a bunch of requests fired off real quickly, and